All right, welcome to this explainer. Today, we're going on a bit of a journey. We are going to track the absolute evolution of a startup's architecture. We're going to watch a system grow from a single, honestly highly vulnerable laptop into a massive, globally distributed network that can handle millions of users without breaking a sweat.
Think of our system kind of like a video game hero leveling up. We're going to hit 6 major stages today: the single server setup, vertical versus horizontal scaling, balancing the load, speeding up with CDNs, the stateless web tier, and finally database sharding.
Okay, let's jump right into stage 1, the single server setup.
So, it's day 1. We've got the most basic setup imaginable. Literally everything, the web app, the database, the cache, is crammed onto one single machine. But to survive, we got to evolve fast. Our very first move, drawing a line in the sand. We separate the web tier, which handles the user traffic, from the data tier, which actually stores our stuff. This lets them scale totally independently, and it's an absolute must-have foundation for everything else we're going to build.
Now, before our data gets completely out of hand, we have to make a call on our database. Most developers, myself included usually, default to traditional relational databases. Tables, rows, the whole shebang. They've been rock solid for over 40 years. But if we absolutely need super low latency, or if we're dealing with massive amounts of unstructured data that just needs serializing like JSON or XML, then pivoting to a NoSQL database might actually be our best bet.
Moving right along to stage 2, vertical versus horizontal scaling.
So, the app's a massive hit. Awesome, right? Except, now our poor servers are absolutely groaning under the traffic, forcing us to pick a lane. On one hand, we've got vertical scaling, scaling up. This is the easy route. Just throw more raw power, more CPU, more RAM at your existing server. On the other hand, we have horizontal scaling, scaling out. This means we add completely new servers to the pool to share the load, which gives us some much-needed failover redundancy.
And look, vertical scaling has some really hard limits. Sure, you can build absolute monster servers. Back in 2013, Stack Overflow was handling over 10 million monthly visitors on just one massive master database. Crazy. But there is a hard hardware ceiling. You literally cannot add infinite memory to one machine. And honestly, trying to push those physical limits gets astronomically expensive.
But here's the real kicker. We absolutely have to treat vertical scaling as a giant red flag for large-scale apps because it introduces a SIF, a single point of failure. Think about it. If that one mega server goes offline for any reason, boom, the entire startup dies with it. There's literally zero failover protection.
All right, stage 3, balancing the load.
So we know we got to horizontally scale out to survive. But how on earth do we route thousands of unpredictable users to multiple servers without it turning into total chaos? Enter a real game changer, the load balancer. Think of it as a highly efficient traffic cop. It sits right at the front, intercepts all those public requests, and safely routes them to our web servers using private IPs, keeping them safe from the open internet. And the best part? If server 1 decides to crash, the load balancer just gracefully reroutes everyone to server 2. Crisis averted.
Now let's peek at the data tier. To protect our database from that exact same single point of failure trap, we replicate it. We set up a master database to handle all the heavy lifting for data modifications, the writes, updates, deletes. Then we clone it to multiple slave databases that strictly handle read operations. Since most apps are way heavier on reads than writes anyway, this massively boosts performance and guarantees we've got backups ready to tap in if one fails.
Which brings us to stage 4, speeding up with CDNs.
Okay, our core is stable. Next up, we need speed. We have to drastically slash load times for users who might be geographically halfway across the globe from our data center. We do this with a CDN, or Content Delivery Network. Basically, it's a geographically scattered network of servers that caches our static stuff, images, videos, JavaScript, closer to the user. This simple 4-step flow shows exactly how we keep that heavy lifting off our main servers. User asks for an image, the local CDN checks its cache. Missing? It fetches it from us just once, caches it, and hands it over.
You can actually trace that exact journey right here. User A asks for a photo. The CDN doesn't have it, so it grabs it from our back end. But then user B asks for that exact same photo. Boom, the CDN serves it up instantly from its own cache. It's incredibly fast, and it ensures our databases only ever get hit once for those high-volume static assets.
Take a step back and look at our map now. We are evolving, folks. It's turned into a seriously robust network. We've got a beefy load balancer acting as a shield up front, a CDN providing global air support, plus dedicated caching layers, message queues for handling asynchronous background tasks, and those replicated databases holding down the fort in the back.
On to Stage 5, the stateless web tier.
Now, if we want true auto-scaling, where servers just magically spin up and down based on live traffic, we have to confront a sneaky trap: user session data. Check out the stark difference here. On the left, a stateful architecture. The server remembers everything. User A is completely locked to server 1. If server 1 crashes, user A gets booted out completely. Not a great user experience, and it requires messy, sticky sessions. But look at the right side, the stateless design. Clean, elegant, infinitely scalable. We just rip all that session data out of the web tier entirely and dump it into a shared, persistent NoSQL database. Suddenly, any web server can handle a request from literally any user.
Finally, Stage 6, database sharding.
So you hit millions of users. Awesome problem to have. But eventually, even that fancy master-slave setup is going to hit a physical hardware wall. We have no choice but to slice up the data itself. Enter database sharding. We chop one massive database into smaller chunks, or shards. Every shard shares the same structural schema, but holds totally unique data. To figure out exactly where a specific user's data lives, we use a math trick, a hash function. Like, take their user ID, run a modulo 4 on it, and bam, you instantly route them to their specific data bucket.
But hey, sharding is definitely not a magic bullet. In fact, it brings up a really entertaining, but honestly terrifying technical scenario. What on earth happens to your system when Katy Perry, Justin Bieber, and Lady Gaga all randomly end up on the exact same database shard?
Welcome to the dreaded celebrity problem, or the hotspot key problem. If you're running a massive social media platform, and heavy hitters like that share a single shard, their millions of followers will literally crush that specific server with constant read operations. It creates a devastating bottleneck while your other servers are basically just twiddling their thumbs. To fix it, you usually have to build custom routing, where a single celeb gets their very own VIP shard.
So the big takeaway here, sharding enables infinite growth. Yeah, but you are absolutely trading simplicity for some hefty operational nightmares. You've got to actively manage resharding when a database gets stuffed, actively police those celebrity hotspots, and because your data is now physically scattered across different servers, running simple join operations becomes incredibly difficult. You often end up having to denormalize your entire database just to make things work.
But man, despite all those database headaches, just look at what we've built here. This is our fully evolved Year 5 architecture, an absolute masterpiece of system design. We've gone from one fragile laptop to a completely automated, stateless fortress. Web servers dynamically auto-scale, heavy assets are globally cached with CDNs, message queues completely decouple our background jobs, and our databases are sharded to the moon to handle anything we throw at them.
You now know the exact playbook for scaling an app from 0 to millions of users. We've tackled single points of failure, global latency, and crazy server overloads. But let me leave you with this one provocative thought. What is your next architectural move when an unpredictable natural disaster wipes out your entire primary region and this beautifully designed data center goes completely pitch black? Definitely something to chew on. Until next time, keep exploring and building.